There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Setting Sail. This module was a manual that was originally created in the Keep Writing So Nobody Explodes competition. This was from the most recent season, the rebooted season, and I decided to make this module along with the help of Quinn West, so this is the way the module looks. So what we have here is on the module we have a body of water, in this case the Pacific Ocean. There can be a series of several other choices which include the Atlantic, the Arctic, the Caribbean, the Pacific, the Southern, the Baltic, the Indian, and the Mediterranean and the Black Sea. So these are all the possibilities of bodies of water that we can get. We also have a series of 4 different buttons which have 4 unique boats on them. In this case, and one of them is highlighted. So if you look down at the bottom of Appendix M45T, in this case, what we have here is we have a series of sail plans, their names associated with it, and the letter that is associated with it. So, let's have a look. Now, we don't need to define all of them, and the only one that we're going to want to pay attention to for right now, because all we really technically need is at most 2 boats, is we want to pay attention to the one that is highlighted. So in this case, this one is the lugger. In this case, that's going to be starting with a letter of Charlie, in this case. That's what it represents. So, we're going to write that down, and now we're going to do some calculations. So, let's have a look. So, on the module, there are 4 buttons, each displaying a sail plan and a type of water, and a type of boat, and a screen showing the name of the body of water. Now, what we're going to do is we're going to take the bomb's serial number and convert every character to another character using table A. Put this converted serial number after the serial number to form a string of 12 characters. Call this the key. So let's take a look. So we have a serial number of Delta Papa 6, Uniform Tango 7, and let's have a look because we have a table A down here, and in this case what we're going to do is we're going to convert each letter into another letter based off of the series of conditions. Now there is 3 tables present, and each table has only a limited amount of letters that can be used as the column in this case. So A through L, Mike through X-ray, and Yankee through 9, in this case representing all 36 characters. So what we need to do is for each table we need to check based off of a series of ports whether it's XOR, whether both are present, or whether neither are present. Now XOR means one and only one of them is present or true. So let's have a look and let's see what we have here. We have no ports, so it's going to be neither for all of them. Hopefully in the next example we get some more interesting ones, but in this case these are going to be the rows that represent what we're going to be converting our serial number characters into. So Delta is going to be converted into Alpha, Papa is going to be converted into 5, 6 is going to be converted into Bravo, Uniform is going to be converted into Whiskey, Tango is going to be converted into Sierra, and 7 is going to be converted into 8. Now, as I mentioned beforehand, we're going to put this converted serial number after the serial number. So in this case, we're going to keep all of our information, get 12 characters, and we're going to call this the key. Next up, we're going to consult the table B using the name of the body of water, in this case the Pacific Ocean, to get a mathematical expression and get a result from this. So let's have a look and let's see what we need to do. So now we have the Pacific Ocean. The Pacific Ocean wants us to do A plus C times this by B in parentheses. A plus C in parentheses, and then after that result we're going to multiply it times B. Now, we have the ability to take a look down here. A equals and B equals and C equals. Let's figure out what each of these equal. So A is equal to the batteries times battery holders. Let's have a look. So we have 1, 2, 3 batteries times 2 battery holders. 3 times 2 is going to be 6, so A equals 6. Bravo and Charlie. So Bravo is going to be ports times port plates. Well, we actually didn't have any ports. We only have a port plate. So that's going to be 0 times 1, which in this case is going to result in 0. Now, pay attention to the symbols that's going to be noting down here. C is the number of modules plus the starting time in minutes. It's very important that you pay attention to this. So number of modules, in this case, is 1 plus the starting time in minutes. Every time I start off with 120 minutes, so in this case, 1 plus 120 is equal to 121. Now, one of the things I should have recognized in this example here is the fact that Bravo is going to be 0, and anything multiplied by 0 is going to be 0. So already our answer is going to be 0. Now, we need to calculate the expression, which we just did. In this case, that gave us a total result of 0. Now, what we need to do is we need to convert the result to ternary. We're going to call this the instructions. So 0 in ternary, which by the way, for those of you who don't know how ternary works, is it's going to be 3 to the power of whatever. That's basically base 3. So I think you could have like up to like 5 or something like that. It can vary how often you do this, but it's like 3 to the power of 4, 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, and then 3 to the power of 0. And each of these values, when we pop it into calculator here, if I can get it up, there we go. So 3 times 3, 3 times 3, in this case would be a total of 81. 3 times 3 times 3 is going to be 27, and 3 times 3 is going to be 9, 3 times itself is just going to be 3, and then 3 to the power of 0 is just simply going to be 0, is going to be 1 in this case. Anything to the power of 0 is always going to be 1. Now, with ternary, it works a little bit different compared to binary. For those of you who are familiar with binary, where it's like you just simply add up every number that you have, there is the possibility of there being, like having, for example, 2 81s in it because of the fact that it can be either 0, 1, or 2, as representing by the numbers here. So, if we were to say, for example, have to do, I don't know, 256 in ternary, which let me just make sure, 81 times 3, 81 times 3, we want to use this. Okay, so 3 to the power of 5. Bring this in. Space it off to the side. 243. I should know these by now. But in this case, if we wanted to convert this into ternary, if we got 256 by some random example here, what we would do is we would then do 256 minus 243. In this case, we can only do that one time in order to allow it to fit in. So in this case, that would be a 1 for that position. 81 cannot fit into 13 for the remainder. It cannot fit into 27. It can fit into 9, so we can subtract 9. In this case, calculator. Subtract 9. It can only be done once. 3 can be done only once. Minus 3. Yep. And then we can only subtract 1 from 1. So and that would be the result in ternary. Now, say if it was 257, all we would simply do is change this 1 to 2. That's going to be the way that would work. So that's just gives you an idea of how ternary works. However, in this case, we simply get a result of 0, which 0 in ternary is simply equal to 0. Everything in every base is equal to 0 when it is equal to 0. So now, one of the scale plans will have a red outline. In this case, we determined that beforehand, and it was Charlie. In this case, if we look down here, the lugger. Now, one thing I should note down is that sometimes some of this manual will look a little bit different. Some of them might look a little bit condensed or like squeezed a little bit. That's just to fit on the button. I would advise not worrying about that for right now. And describing these ships might be a bit difficult, and attention to detail is very important because some of them look very, very similar. So make sure that you figure out a description. What I would advise probably is, for the most part, I would actually probably define like vertical lines, like those big vertical lines, like this one, for example, would be, it's not Barca. I just saw it, I think. I believe it's fully rigged ship right here, yes. So, in this case, I would define this as like 3 lines, each of them, the first 2 have 4 that are fully out, and the third one back there has the first 3 that are fully out from top to bottom. And then on the far right side, it's got another dark blue bit off to the right there. That's kind of the way that I would define it. And then, of course, defining the front as well. Three triangles, light, medium, and then darker. It just kind of goes darker. Now, some of them are very easy to describe, like Gunter and Junk, for example. Some of them are very easy on their own. But in this case, we're looking at Luger. So we're only going to focus on the highlight one for right now, and we're going to try and get a sail plan that we're going to be taking later on in order to determine this. Now we're going to get to this bit. So, and this is going to be the starting node at the octagonal diagram. So in this case, we're going to be starting at the node of Charlie here. So over in the top right here. That letter is representing our starting position. Now what we're going to do is we're now going to be moving around in that grid. So begin at the first character of the key, so in this case we've got the key here, and then perform a movement on the octagonal diagram based on the first digit of the instructions. Move to the second character of the key and the second character of the instructions, perform that movement and repeat until all of the key has been used. Note that we're not doing it until all of the instructions have been used. We're using it until all 12 characters of the key have been used. So now, If the last digit of the instructions is reached, loop around, and the key does not loop around. So in this case, what we're going to essentially do here is, since we have a result of 0 as our ternary, we're just going to spam it. So in this case, we get a total of 0. This one is definitely an easy example, and I hope to get a different one next time around, so stick around for that. But in this case, this is what we're going to be working with here as regards to instructions. And we're going to press the edit button with the sail plan that corresponds to the letter labeling the node reached at the end of the movement to solve the module. Now, in order to, one thing I should note is that the solve plan that we start on could actually be the one that we end on, just as a mention. So, now, in order to determine the movements, this is the last bit of the module, so the character of the key being used determines how much to move by. If it is a digit, simply use the digit. If it's a letter, take the alphabetic position of the letter plus 9, and we're going to simply modulo by 10. So, in this case, we have a delta. Delta is going to be a 4 plus 9, which is going to be a 13 because it's a letter. We're going to modulo this by 10, and it's going to be a 3. Basically, what you can do is just a nice simple way of visualizing it, is you're taking the last digit of its position and then subtracting 1. So in this case, Papa is 6. In this case, it would be 16 plus the 9, which is going to give us a 5. So in this case, it's 6 minus 1 is 5. The digit is 6, so leave that alone. 21 plus 9 is going to be 30, so it's going to be 0, and as you can see, it's proving consistent. Now, of course, for cases of starting on a 0, for the last digit being a 0, we're obviously going to want to make this 9. So this is going to be 9, this is going to be 7, this is going to be 0, this is going to be 5, this is going to be 1, 23, this is going to be 2, 19 is going to be 8, and 8. And these are going to be the movement amounts that we're going to be moving by. Now, what exactly does the ternary do for us? If it's a 0, we're going to move clockwise. If it's a 1, we're going to move counterclockwise. And if it's a 2, we're going to switch between the inner and outer octagons. And that's going to be what's going to happen here. So, the way that moving between inner and outer octagons is very particular, and I kind of want to focus on it next example if I get some 2s, which is going to be very important. So I'm going to skip explaining this until later on. Actually, I will explain it right now. So let's say if I just wanted to put in some 2s here randomly, for example, this is not part of an actual sequence. So let's say that or rather, let's do it at the beginning, because that's just a little bit easier to explain. So we start at Charlie, and let's say like the first one was at 2, for example. So in this case, Charlie is where we begin. If you are on a node between 2 corners, whenever you switch octagons and you are on a corner node, simply move to the corner node at the corresponding corner of the other octagon. So in this case, we want to move to the top rightmost corner, so on the other octagon. So in this case, that would correspond to delta if we were moving from Charlie into the inner octagon. So in this case, delta. Now, if we were to do, for example, moving clockwise 5 times, 1, 2, 3, 4, 5, say if it was Sierra, and then we were to do 2 here, we would want to move to the leftmost, which in this case would be a Mike. Now, if we had to move clockwise 1, for example, let's just say that that's a 1. So if we had to move clockwise 1, and we had to go to November, and we had to do 2 here, so November here in this case, what we want to take a look at is this specific rule. If you are on a node between 2 corners, which in this case is indeed true on the outer octagon, and this only applies to the outer octagon, I should mention, move clockwise 1 node if the calculated value in the key is even. Counterclockwise if it is odd, then move to the corresponding node in the inner octagon. The exception to the moving is from delta or foxtrot, in which case you simply retain your position. In this case, delta and foxtrot are both corners on both the outer and inner, and on the it's corners in the inner, and it is in the middle of the outer bit. Those are just going to stay the same. That's the only exception. So in this case, if we were to go 1 clockwise to November, and we were to switch, for example, we would take a look at the value of our key here, and in this case, the last digit is a 9. So in this case, what we're going to do is we're going to move counterclockwise, back to Mike, back to Sierra. And that's going to be the way that that's what we want. So that just gives you an idea of how this actually works. In this case, we're simply going to disregard all of this information. I think I did everything correctly. Let's move back. And that should be good. So what we're going to do now is, starting from Charlie, 0 is going to be moving clockwise, 1 is going to be moving counterclockwise. It's very straightforward, and 2 is obviously going to be switching. In this case, we're going to be moving clockwise. Now remember, we're moving clockwise via the amount in the key. So in this case, let's bring Charlie up as our starting position. So from Charlie, we're going to move clockwise 3 times. 1, 2, 3 to Foxtrot. Clockwise 5 times. 1, 2, 3, 4, 5 to Kilo. Clockwise 6 times. 1, 2, 3, 4, 5, 6. Clockwise 0 stays in Alpha. Clockwise 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 to Juliet. Juliet is going to go clockwise 7. 1, 2, 3, 4, 5, 6, 7 to Alpha. Alpha stays Alpha because we're not moving anywhere. 1, 2, 3, 4, 5 to Foxtrot. 1 to Golf. 2 to India. 8 times for each of these. So 1, 2, 3, 4, 5, 6, 7, 8 to Alpha. 1, 2, 3, 4, 5, 6, 7, 8 back to India. So now what we want to do is we want to find the ship plan that has our final letter corresponding to India. Let's scroll down here. In this case, India corresponds to what? The schooner. We do have this present on the module in the bottom left. And just like that is a solved module. That's all there really is to it. It's a very simple module to do. The moving around bit can be a bit wacky sometimes, so just be very careful with how you move it. But overall, it's a very simple process. Very medium module. So let's pop up another example here real quick, and hopefully we get one that's a little bit more diverse in the ternary, rather. Something that isn't just 0. Now, if you do get 0, that is a quite a nice case, because you're just simply going to be moving clockwise the entire time. So if you do want to reset for that, then like by all means be my guest. Although I would argue that it isn't worth it because it's a module that's pretty easy to deal with. So let's take a look at one final example. It's a very fun module. I quite like the idea of it. This is why I made it. So let's have a look. All right. So our body of water is going to be the Arctic Ocean. Okay, it's going to be A plus B plus C, so we're not going to get 0, unfortunately not around this time around, because we're going to have this C being the number of modules plus the starting time in minutes. So, we're going to definitely have some big stuff first. So, I'm going to calculate the formula first, real quick, actually. A plus B plus C, in this case, A being batteries times battery holders, we happen to have 4 times 2, that's going to be 8. Bravo is going to be ports times 4 plates, we got 1, 2, 3, 4. 4 times 3 is going to be 12. And number of modules, 1, plus the starting time in minutes, 120, so 121. Obviously, we'll change it via which bomb you start on, so just make sure that you note down what the starting time in minutes actually is. So we've got 8 plus the 12 plus 121, big boy. So 141 is going to be our value in ternary, our value that we need to convert to ternary. So let's do that. Cancel. So remember, we had 3 to the power of 4 was 81. I believe we're going to get at least 1 in there. So 3 to the power of 3 was 27. Then we had 9, then 3, then 1. We're definitely going to be getting these. 3 to the power of 2, 3 to the power of 1, and 3 to the power of 0. Just to give you guys an idea of what we're looking at here. Okay. So 141 minus 81. We can only do that one time. 1. We can do 27 twice. So 27, 1, 2. That's where we put in a 2 here. We can do 9 0 times, so that's not going to go anywhere. We can do 3 2 times, and we can do 1 0 times, because we're going to be subtracting 3 twice here, and we get 0. And just like that, that is our ternary. This is a much better ternary to work with and actually show you guys what we're dealing with. So we're going to do this, and we're going to copy it until we get 12 characters from this. So, and then we got 1 2 at the end. That should be a total of 12 characters. It is indeed. So that's all we simply need to do with that. So that's our instructions here. Now for our key. So our key, the first 6 characters is obviously going to be the uniform delta and the civil serial number. Uniform delta 3, Lima Papa 2. Now let's figure out what we're looking at here. So we've got PS2 present, X or DVID. Yes, we do have the DVID only. The PS2 port is not present. RJ45, X or serial port. We do have the serial. Yes, that is indeed true. So, and there is no RJ45, so that's going to be true as well. Parallel port present, or X or stereo RCA. We do have the stereo RCA and the parallel port, so both of them are present, so that's going to be the order. Okay, so we've got uniform. Uniform corresponds to golf. Delta corresponds to kilo. 3 corresponds to Juliet. Lima corresponds to hotel. Papa gives us Oscar. It's very important that you note down that the zeros have the slash through them, I should mention. And then 2 is going to be a Victor. Okay, and now let's take a look. Let's figure out what our starting position is going to be in the table. So let's have a look here, and we'll get the directions amount rather. So in this case, this one, let's find it. It's got 2 poles. It's got first one has all 3 up. Second one has the first 2 up. I believe this one's snow. It looks like it's snow. Yeah. So starting with delta. Now let's go for the amounts. Remember that we're going to be doing +9 for letters to just say the exact same. So 21% is going to be 0. 4 becomes 3. 3 stays as it is. 2 becomes 1. 6 becomes 5. 7 becomes 6. 1 becomes 0. Juliet becomes 0 to 9. 8 becomes 7. 5 becomes 4. And 2 becomes 1. Now, the way that I'm doing this, the way that I'm specified is like, for example, with Victor, I said 22, which in this case, I'm focusing on the last digit being 2. Since we're adding 9, it's basically decreasing the least significant digit by 1. It's all you simply need to do with that. It's a very nice, simple way of actually making it their life simple. So, we're going to start on delta, and we're going to follow the instructions. So, now we have a wide variety of actual numbers here. We actually have some numbers that we can work with. So, 1 is counterclockwise, 0 is clockwise, 2 is going to be switching between the inner and outer octagons. So, we're starting in delta, and in this case, the octagon in which you started is determined by initial position, with D, E, F being considered part of the outer octagon position. So, when you start in this position, what this means is that when you start in delta, echo, or foxtrot, you're going to be part of the outer octagon. It's very important to note that down. So, okay. So let's take a look. So we've got delta here. We're going to be moving. Counterclockwise by 0, so that stays the exact same. So delta. We're gonna swap between inner and outer. Now it doesn't matter because of delta being part of this rule here. If the exception is moving from delta or foxtrot, in which case you simply retain your position. So we don't care where this is going. We just know that for a fact it's going to stay in delta. But now we're in the inner ring. We need to note that down. So delta, we're going to move clockwise 3 times in here. So 1, 2, 3 to uniform. We're going to switch to the outer octagon now. So it's going to be so bottom position is going to be India. We're going to move clockwise 5 times. 1, 2, 3, 4, 5 to November. We're going to move counter 2 times to Lima. We're going to swap into the inner. Now in this case, this is a middle point. This is the Lima. The amount that we want to move on the key is even. So in this case, we're going to move clockwise. So from Lima, we're going to go to Mike. Then we're going to go to Sierra. We're going to move clockwise 0. That's going to be Sierra. We're going to go back to the outer ring, which is going to be a Mike. We're going to go counter. We're going to go clockwise 7. So 1, 2, 3, 4, 5, 6, 7. That's a delta. We're going to go counter 4. 1, 2, 3, 4 to Papa. And finally, we're going to go back to the inner ring. But from Papa, since our amount is going to be an odd, we're going to go counterclockwise. Oscar, then to Romeo. Our final position should be Romeo. Let's find the letter that corresponds to it. Junk is indeed present. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.